Okay guys, so today we're going to talk about the first lesson in our new unit of circle segments. I'm talking about two intersecting chords today. Basically, when we have two chords that are intersecting, we're not going to talk about the angles like we did before. What we are going to talk about is the actual segment length. So let's get right to it. First thing we're going to talk about, when two chords are intersecting, basically it's broken up into each chord is going to be broken up into two different parts. Here I have BE and AE, and this chord is broken up as CE and ED. So what happens is we take the product of the two parts, and they're going to be equal to the other product of the other two parts. And sorry, that was a bad explanation, but basically you multiply these two parts, it's going to be equal to the product when you multiply these two parts. Okay, so in this case, we have the formula. When you're given this situation, you have AE times EB is equal to EC times ED. And let's go over that again. AE times EB is equal to CE times ED. Okay? Now, if that's the case, we can easily be able to figure out all the line segments given three pieces of information about the lines. Okay, let's go over three examples and then basically call it a day. Let's take a look at the first one. If AE is 5, EB is 4, and CE is 2, find the length of ED. Now, this is a very basic example, and on the New York State Regents exam, they always seem to ask one question about these things. So, AE is equal to 5, EB is 4, CE is 2, and I want to know what ED is. We don't have an X involved, so what we'll do is we will plug in X. Now, we do the product of the two segments created at the chords with the intersection. So I'm going to do 5 times 4 equals 2 times x. Now when I do that, we get 20 equals 2x, and x is equal to 10. And remember, x is the length of ED, so we do ED is equal to 10. Okay? Now, let's take a look at another example. AE is equal to 9, AB is 14, and CE equals 3. Find the length of ED. Okay, so now, let's do this real quick. AE is 9, AB is 14, and here comes a little trick question. When AB is 14, that's not part of the chord that's being broken up, it's the whole thing. I'm going to put that little bar around it, say the whole thing is 14. And then CE is 3, and we're looking for ED again, so I'm going to make that X. Now, in this case, what we do is you first need to figure out what EB is. And if the whole thing is 14, this part is 9, then this part must be 5. And the way we figure that is 14 minus 9 gives us 5. Okay, now once we do that, you can set up our equation. 9 times 5 equals 3 times x. And you do that, you get 45 equals 3x, and x is going to be equal to 15. Okay? And remember, x is ED, so ED is actually equal to 15. Okay, our last example, and I of course had to toss in one of these lovely problems. We are dealing with a ratio now. Now, the problem says the ratio of AE to BE is equal to 2 to 3. If CE equals 3 and not CE, whoops, ED, apologize about that. So ED is equal to 10, find the length of AB. Now, the key thing is, when you have a ratio, and there's no other x's involved, we could say this is going to be two parts, so we call this segment AE matches up with the 2x, and BE matches up with the 3, we'll call that 3x. Now, CE is equal to 3, and ED is equal to 10. Now, we do the same thing we've done before over and over and over. We do 3 times 10 equals 2x times 3x. Now, when you do this on the left, we're going to get 30. It's going to be equal to, I have 2x and 3x. Remember, multiply the numbers together, so 2 times 3 is 6, and x times x is x squared. Don't think it's 2x. Now, we have to divide by 6 first, and you get x squared equals 5. And then finally, we can say x is equal to the square root of 5. So when you're looking at this situation, you're looking for what AB is. So we know that AE, I can replace x's square root of 5. So this is really 2 radical 5, and this is 3 radical 5. Now, we're looking for AB, and I have both parts, so we're going to add them together. So I get 2 radical 5. Sorry, AB is going to be equal to 2 radical 5 plus 3 radical 5. And remember, when you have this situation, you leave the radicals alone, and you just add the coefficients. So AB is going to be equal to 5 radical 5. Yeah. That's probably the most complicated type of example you'll see, but that's basically it. And that's pretty much it for this lesson. So if you have any questions, feel free to make a comment, email me, do something. Yeah, other than that, have a great night. Bye.